which I will represent as capital letter F, evaluated at what? A and what? B. So generally, that function you get, you're going to substitute B first, minus that same function evaluated at point A. And if you do this, then you are correct. All together? So, I'm going to be giving you some examples. Please write. So, this is going to be what? Definite integral. Definite integral. Fantastic. Now, I'm going to be giving you some examples. I will try as much as we can. Maybe if you are in this class, you try to raise the board or something. I don't understand. So we used to do it before. We used to raise this board. I don't know somehow. Okay. I don't think this is just 1, 2, 3, 4, 5, 6, 7, and the board is because that's what I read. So I don't know how to speak and write. So for that reason, I'm just going to be detecting some equations. Yes. Now we have the y upon the x is equal to, please write. The y upon the x is equal to 30x squared plus 3. Right. So they now say, what did I say? For instance, we have the y upon the x is equal to what? 30 what? Plus 3. They can ask you what is y. Like I said, since we know that differentiation and integration, they are opposite. So all I need to do is to integrate this function. Then I'm going to get y. Right? So can I simplify this? Can I simplify this to become the y is equal to 30x squared plus 3 dx. Is this the same thing? Is this the same thing? People sitting at the back. All I did was what? Cross multiply. Is that also? So I take x dx to the other side. Now see, I'm going to integrate this. Then integrate it. Are we together? I will integrate both sides. Right? Now, what do you think this side will be? That place is something as saying integral of what? 1 dy. Is that not so? Is that not so? Are we together? Now, let's simplify all of this part. What do you think is the integral of 1 dy? Yeah? It's the same thing as saying y raised to power 0 plus 1 now. It's not also upon what? 0 plus 1. together? Fantastic. But let's do this guy. What are we going to get? Integral of that guy. We can do it as the same thing as integral of 30x squared plus 3. We can do this way plus integral of what? 3 dx. Are we together? It's going to be the same thing. You can do it the way we did this one, you can do it the way we do this one. It's the same thing. Provided what you have here is what?
Plus.
Is what?
Plus.
Plus. Or minus. Now, similarly, I can decide to push out the 30 out because it's a constant, right? Do you understand me? This is a constant. I can put it behind the integral. So I can say 30 integral of x squared dx is the same thing by the power of what? This guy. Are we together? Good. So I can decide also here to push out the 3 outside. So I have integral of what? Dx. What is the integral of this? That is what? X raised to the power 3 upon what? Fantastic. Plus, what about this guy? What is the integral of dx? It's going to be what? X. Multiplied by what? X. It's just the same thing that happened here, right? So here, after this integral, we're going to get what? Y. So we have y is equal to what? What can I reduce? Remember, we have not added plus or what? K. Constant of integration. 3 can go inside 30, right?
Yes.
So how many is that?
Yes.
X what? Q. 3 multiplied by x plus 3x plus k. It's as simple as that. Any ambiguity? Not here. Any problem? Not here. Yes, talk to me. The audible? Okay, I shall explain. Now, you are given a function, dy dx. Right? This is dy upon dx. This is the function. And you are asked to find y. How can you do that? It's very simple. All I need to do is to cross multiply so that I have dy here and dy at the other end. Then I will now integrate both sides. In the exam, I would like you to be telling me what you're doing. Yes. That's how I know you did not copy from somebody else. You tell me that cross multiplying, you now have this. This next step, you say integrating both sides. Simple. So when you integrate the y, you're going to get y. Now when I want to integrate 30x, I say you can do it straight. For instance, integral of 30x squared dx. I can do it without pulling out the constant. It is going to be what? 30x raised to power what? 2 plus 1 upon 2 plus 1. Is that also? What is 2 plus 1? It is 3. What is 2 plus 1? It is 3. 3 into 30 is 10. Are we together? So you can do it anyway. It is still the same thing. Any confusion? Not yet. Yes? For the 3x, fantastic. If you want to do 3x straight, right? You have integral of a constant 3. X is equals 0 plus 1 upon 0 plus 1. Any confusion? It's a constant. When you are integrating a constant, just add x to it. Your answer is going to be what? 3x. So integral of 100. Integral of 100 dx is going to be what? 100x. It's going to be 100x. In fact, if you have integral of k dx, it's going to be what?
Yes.
Simple. It's going to be kx. Fantastic. Are we together? As explained, when you are integrating a constant, it is the same thing as saying that constant multiplied by x. Constant can be anything. Constant can be 100, can be A, can be B, can be 5, can be 1. Right? But it is differentiation that is going to be 0. But I told you that differentiation is anti-integration. Integration is anti-differentiation. Are we together? So see, which means if I should differentiate this guy, if I differentiate this one, I'm going to get that result. If I differentiate this one now, I'm going to get this one. Is it true? Is it true? Eh? It is true because if I want to differentiate this one, differentiation is multiply and minus 1. Is that not so? So if I multiply this, I'm going to get 30x raised to 3 minus 1, which is what? 2. Right? What about here? It's 1 that is here, so I'm going to get 3 raised to power x, 1 minus 1, which is what? 0. And anything raised to power 0 is what? 1. If I differentiate the constant is what? Is 0. Can you see it has gone back to this? Do you understand? So if you differentiate, if you integrate something, you're going to get an answer. If you differentiate that answer, you should get the result. Good. Now let's see. Let's go to an example that has boundaries. An example that has boundaries. Let me use this one, it's very fantastic. Let me give this example before we continue. One minus x upon 3. This is what we have. Integrate 1 minus x upon x raised to power 3 dx. You are giving something like this to integrate. With what you know now, can you integrate it? The answer is yes. Do you understand? Now let me give you the simple step you use to integrate this. You have a common denominator over here. Is that not so? You have a common denominator. Go back over. I can decide to split this. I can decide to split this to 1 all over x cubed minus x all over x cubed or yes. Have I done anything? Have I done anything? Look at it very well. Have I done anything? No. Since the denominator is the same, I can decide to split what is up. Is that not so? Now, from here, anybody can do this. Is this not the same thing as integral of 1 upon x cubed dx minus what? Yes. Here, 1 guiding cancel. So I have 1 all over x squared dx. It's not the same thing. I told you if it is addition or subtraction, you can split the integral. Is that not so? Yes. Is that not so? So I can continue further to say, okay, from indices, if I should take x squared up, what will happen? If I should take x cubed and x squared up, what will happen? Eh? The positive will change to what? Negative. Simple math. So here I'm going to have x minus 3 dx minus what? Yes. Integral of what? Yes. X minus 2 dx. You see how much is simple. But initially we will say that this thing is something very big. But do you see how simple it is? What did I do? Let me repeat. I split the integral into two. It's just like two portions. The first portion is 1 all over the denominator. The next one is this part upon the denominator. I can bring it back. If I take the LCM is what? X cubed. I can always bring it back. Right? So I decided to split the integral since it is the same thing. What is separating them is what? It's just minus. If it is multiplication, you cannot separate them. Please. Do you understand me? Are we together? And even this thing is multiplication, you can't separate the integral. We'll now find another type of integration to use. Do you understand? Now, I have split them into two because it's minus. Now, this part is very simple because I can use indices to push this x squared up. If I do that, the positive here will change to what? Negative. And even it is negative. And even it's negative. Going up, we make this become what? Positive. Are we together? Fantastic. So in our case, we have negative. Who cannot do this now? Anybody can do this. So what are we going to have? X raised to power minus 3 plus what?
1.
Upon what?
Minus
3 plus 1. We have minus over here. Then here we're going to get what?
Yes,
Minus 2 plus 1 upon what?
Minus 2
2 plus 1. Plus what?
K.
Fantastic. Plus k, constant of integration. Right? So in that case, here, minus 3 plus 1 is what?
Minus 2.
Eh?
Minus 2.
So I'm going to get x raised to power minus 2 upon what?
Minus 2.
Upon minus 2. Here I'm going to get minus what?
1.
X raised to power what?
Minus 1.
Minus 1 upon what?
Minus 1.
Minus 1 plus k. Can you see that this minus 1 can be plus? So my final answer here, I can have what? I can have minus x raised to power minus 2 upon 2. Then here will be what? Plus x raised to power minus 1. Then plus constant k. Fantastic. You know I can still push it down, right? Do you know I can still push this down? So I can make it to be 1 upon 2 raised to power 1. If I don't want that negative to appear, then here will just be plus 1 all over what? X. You know it's the same thing, right? Fantastic. So I'm going to give you an example of bounded integral, and then we'll continue from there. Fantastic. Are you done? Like wipe out. Yeah. Fantastic. So now, if you are giving two functions multiplying each other, right? I told you guys that you cannot separate them like this. But what you can do, if they are polynomial functions, that is, if they are quadratic or they are linear, you can multiply them out. And then what will be separating them will be plus, plus, plus. This thing is grammar. Let me write it down. Wait, can you tell me everything? Where? This place? What I'm speaking right now is French. Let me come back to maths. This is what I mean. Like, I have integral, let me use variables. I have integral of, let's say, ax plus b, right, into cx squared plus, like, let's say, d, right? Now, this dx. Now, remember I told you, can you just integrate this and then multiply by the integral of this? Can you do that? No. You see, what is here is what? Multiplication. So you cannot integrate this, then come and integrate this. It is what? Wrong. But you can do this. I can multiply these two together. If I multiply these two together, what will be separating each of them is going to be what? Addition or subtraction. Is that not so? Let's try it so that we'll see. If I multiply this and this, I'm going to get what? ACX what?
Square.
Fantastic. Is that not so? Then multiply this and this, I'm going to get what? ADX. This and this is going to what? BCX. This and this is what? B and D. Can you see? Right now, what is separating them is what? So I can now take integral of ACX squared dx plus integral of ADX dx plus integral of BCX dx plus integral of what? BD do what? Dx. Do you understand? Are we on the same page? Now, for that reason, let me now give you, yes, for instance, integral of 2x minus 3 all squared dx. Anybody can do this. What am I supposed to do? I'm going to take the integral of what? 2x minus 3 and then multiply it by what? 2x minus 3 dx. So what am I supposed to do next? I will multiply the two out and integrate each one. Do you get the gist now? Is it cool? Why I do it? Multiply these two out and integrate them piecewise. Piecewise, they just do them individually. Why I do it? Multiply the two together and integrate them individually. Do it. You have 2 minutes. 2 minutes. Let's do this one, then we'll do 2 more, then we'll do some definite integral, then I will just tell you the type of integration, and we'll be done for today. Right? Hope you guys will not have lecture throughout today. You have throughout today. Okay, so what is your solution? What did you get? Yes? What did you get? Okay, so you got 4x cubed over 3 minus 6x squared plus 9x. Who else got that? You have finished your plan. What did you get? You're not done. Okay, call it for me now. Minus. Yes. Plus what? Plus 9x. Yes, it's correct. What did you get? Okay, yes. It's correct also. Now, technically, if you do it properly, this and this, you get 4x squared. 4x squared.
Yes.
If you now integrate, you're going to get what? You're going to get what?
4x cubed.
You're going to get 4x cubed. It's not all over 3.
Yes.
Is that what you get? All of you are saying yes and no. If I go now, I will not say anything. Now, let's do one more example. I hope you guys want that. So let's do one more before.
So what is the correct answer?
You say?
What is the correct answer?
What's the correct answer? If I integrate this, I'm going to get 4x cubed upon what? 3. Then the second place, I'm going to get the next one is what? 12, right? The next thing you got is what? Minus what? Minus, I think it's 12x, right? Okay. 4x squared, this and this is what? Minus 6x, this and this is what?
Minus 6x.
And I'm asking you if it is 12, you are keeping quiet. Eh? So you have minus 12 what? X. Then the next one you have plus what?
9x.
9. So I have squared here and 2. I have x here. I have 3 here and 3. That should be the correct answer. Right? So this can divide, then you have 6x squared plus 9x minus 3 upon 4x cubed. That's your answer. Now, let me give you one rule before we go to bounded integral. One more rule. What do I say? One more rule. So long as you live until the day you die, anytime you differentiate the denominator of an integral and it is giving you the numerator, your answer is ln denominator. Let me repeat again. Let me repeat myself. If you differentiate the denominator of an integral value and you got the numerator, your answer is ln what? Denominator. Let me speak it in simple terms. We have up, we have down. Down is what? Down is what?
Denominator.
Up is what?
Numerator.
If I should differentiate what is down and I get specifically what is up, my answer for that integral is ln denominator. Ln what? Denominator. Now let me write it mathematically. Mathematically it's going to be written if I have the integral of all of you that are buying ready to change your English. If I have this function, let's say this function is, let's put it anything, call it anything. Just give it, let's use our f of x job. If I differentiate what is down, so which means if I now get f of x down, here is a function. If I differentiate it and it is here, my answer is going to be what? Ln what? See, God will bless you. Simple life. So for example, right? 4x minus 2, 4x minus 4 upon, let me write it down. Integrate 4x minus 4 upon x squared minus 2x plus 5 dx. Don't call that teacher a very wicked teacher when you see this in objective. No. We are not wicked. At all. Now, what should be my answer? I will have to inspect this. If I differentiate this guy, am I going to get this guy? Let's try it now. Let's differentiate what is here. Differentiating this one, I have what? I think there is 2 here. Wait, let me check. Like this, it is like this. Is that what is? Can we get what is up? Let's do it. If we differentiate this guy, what are we going to get? We get what?
2x.
And then what?
Minus.
Minus 2. This is 0. Is it the same as the numerator? Is it the same? Like it's almost. So, what are we going to do? Let's try and rewrite the numerator. See common sense now. We can write this as what? 2 into what? 2x minus 2. Do we have sense or not? We have sense. X minus 2x plus 5 dx. Do we have sense or not? We have sense. And common sense also told us that if you have a constant, we can decide to clean it and write it where? Outside. Oh, this math is simple. Can you see? So, without these two, if I differentiate this guy, am I going to get this guy? Yes. My answer is what? Leave denominator. Leave x squared minus 2x plus 5 plus constant k. Since I have these 2 here, I can just put it here. And that is my solution. Is the teacher a bad teacher? Yes. How like it? This thing now we are doing, is it not simple? Is it not like my mind and Gary? Eh? It's like bread and butter with a touch of gold. Cheap one. You see how simple it is? Let me give you one more. This one is, in fact, you can even solve this one without solving it on the board. I'm telling you. This one. This place. You see, idea is that if I have a function I'm supposed to integrate back, but it is in a quotient form, that means I have something in the numerator and something in the denominator. I will try and see if I differentiate the denominator and the result I get looks like what is in the numerator, then my answer is in the denominator. I say this, the grammar is too ambiguous. If I can differentiate what is down and it's giving me what is up here, my answer is lean what is down. But when we differentiated this guy, we got 2x minus 2, which is not what is here. But I can factor out 2 so that it will look like when I differentiated it. That's simple. So since I can factor out 2 is a what? 2 is a constant. I can put that constant outside my integral. That's what we did. We factor out 2 here and push it out because it's mathematical. We can do that. So when I differentiate this, I got this. So my answer is lean denominator. So that's why we have lean. This lean is natural log. This thing I can write it as natural log. Lean. This is your calculator. Right? Good. So this is lean, not in, or not I and N. Don't go and copy somebody and just put I and N. It is L, it is L and N. Are we together? Fantastic. Good. So the next example we have is I think I didn't solve it without looking at. But let me use this one now to do both boundaries. Yes. I can use this one for the boundary. We have x squared upon x cubed plus 1. I'm supposed to integrate it the x. And now say I want to use this one to show you both boundaries. So integrate it from 0 to 1. So, see, what does this mean? It simply means I will first of all integrate this thing normally, right? Then I'm going to now substitute the upper bound minus substitute the lower bound. So for this one now, if I differentiate the denominator, am I going to get the numerator? Look at it very well. If I differentiate what's in there down, I will get what's in there up. You say what? The answer is what? Are you sure? Oh yeah, wait. Let's differentiate the denominator, all of us together. If we differentiate this, what are we going to get?
2.
We're going to get
3x squared.
3x what?
Squared.
Does it look like the denominator? Does it? Does not look like. So what do you think we can factor out so that it will look like the denominator? What can we factor out so that if we differentiate this guy, it will look like this guy? 3. So I can factor out 1 over 3, since the 3 is down here, right? So if I put 1 over 3 outside, this thing is the same thing as what? Ln x cubed plus what? 1. Should I put k? Yeah? Should I put k? Are you sure? If you are for yes, say I. If you are for no, say I. So what am I supposed to do? So I'm going to evaluate it at what? 0 and what? 1. That is it. I told you, if it is indefinite, put constant k. Put constant what? C. But if it is definite, if it is bounded, you must evaluate it at what? In two boundaries. See what you mean. Don't just think it's too big. It's like it's not too big. See what this thing means. It simply means inside all this place, I'm going to put 1 for x. So I'm going to get 1 upon 3 ln 1 cubed plus 1 minus, anywhere I see x, I'm going to put 0. So we have 1 over 3 ln x here is 0 cubed plus 1. That is all. That is the whole magana. Evaluate the upper bound minus evaluate the lower bound. This is going to give me what? 1 over 3 ln what? Ln 2. Is that so? 1 raised to 3 is 1 plus 1 is 2 minus 1 over 3 ln what? Ln 1. I have punch it in your calculator and tell me the answer. the type of integral that you have, so that what is it, please? Yeah? Okay, we still have like 30 minutes. Now we have integration by substitution. Write it. We have integration by substitution. I think some tests we used to call it change of variable. Right? Integration by what? Substitution. Number 2, we have integration by part. Say integration by part. So write it down. Then we have integration by partial fraction. Unfortunately, this does not have it. We are going to be doing these 3 subtopics by the next class. So the time we have now, we are going to be using them to solve more examples. Right? More examples. Fantastic. So, we have integral. I'm going to do one more, and then we are going to select 2 boys and 2 girls to do the other ones for us. Please. So the one I have here is, should I write all so that you select the one I'm going to solve?
Yes.
We have integral from 2 to 3 x squared minus 2x dx. Number 1. Number 2, we have integral from minus 2 to 1 x minus 1 all squared dx. Number 3, we have not done any integral concerning trigonometry. Okay, let me look for one. Let me look for 1 or 2. But it's very simple now, or we'll do it in the next class. We have the integral of 0 to 2 x squared minus 7x plus 10, right, dx. Then we have number 4, integral of 2 to pi of sec squared x minus 1x. Okay, if I now give you number 4 in the exam, what will you say? You say I'm the most wicked human being on earth. You can stop the video. So we solve this exercise.